we are back yet again. We have some more examples to solve in this video. The first question here is express each of the following as a single logarithm. But you would notice something strange here, that these logarithms do not carry bases. Can you see? They do not carry bases. Anytime you see a logarithm that does not carry a base, it implies that the logarithm is to base 10. 10 is the common base, okay? So logarithms to base 10 can be written with the basis 10, and if you don't write the basis, all the same, it is understood to be in base 10, right? If I don't write any base, it is understood to be in base 10. It is called common logarithm. All right, we know that these logarithms are to base 10. Now, solution to the first one. We have a quickly logarithm of 4 plus logarithm of 3 log 3 minus log 2. All we have to do is to use the laws, okay? If you notice, the first law states that if you have a logarithm, two logarithms, when you add them together, it implies that you are actually multiplying them as a single logarithm, okay? The numbers as a single logarithm. So you remember the laws. See the laws here? See, let me state the laws here quickly. See, log xy, like this, is always equal to log x plus log y. So I can change this back to this form or this to this form, but this is now a single logarithm. This is split into these individual logarithms, right? So you can add them together. The second law states that log x divided by y is the same thing as log x minus log what? Y. See, you remember this. It means that if I have something like this, and this subtraction implies that there is a division within the bracket, right? Then the addition here implies that there is multiplication. You are multiplying the numbers within the log, all right? And that's it. So let's get back to this question. Now, this first one states that log 4 plus log 3 minus log 2. Here, I'll multiply this and this, then I'll divide them by 2. So this becomes, as a single logarithm, like this, 4 times 3, then division by 2. That is the meaning, okay? The base is 10, but no need of writing it, okay? It is understood to be in 10, base 10. So 2 here, 1, 2 here is 2. And so we have log 6, because 2 times 3 is 6. I'm done with that. Done. B states that we should simplify this. Log 8 plus log 32 minus 2 log 4. 2 log 4. All right. So what to do here? Minus 2 log 4, right? This is it. Between this and this is addition. It implies that the arguments or the numbers within will be multiplied, okay? And then, but then there is a number here. Otherwise, I will have just divided by 4. I have to undo this. Or deal with this first. Okay, so this can be written as log 8 plus log 32 minus, remember the first law and the third law states that, let me write it here quickly. If I have log x raised to power n base p, for instance, can be written as n log x base p. You see, the power can sit here and it can also sit here, anyone, okay? But for now, I wish to undo the power and take it back here, right? Undo this number and take it back as a power. You understand? So now this is the number. I'll undo it from here, make it a power. So it's going to be 4 raised to power 2, right? That's it. All right, 4 power 2 alone is what? This is log 8 plus log what now? 32 minus log 16, because 4 power 2 is 16. And so we can have this is as a single logarithm. Now between this and this now is multiplication, so I can have 8 times 32 as a single logarithm, right? Everything divided by 16 now. This is not difficult. This is just straightforward. Okay, I am dividing by 16 because I have subtraction, minus 16, minus log 16, right? So 8 here 1, 8 in 16 is 2, 2 here 1, 2 in 32 is 16, and so we can have log 16 as our final answer. This is now a single logarithm. Single logarithm, this one is the same thing as the whole of this. All right, the next one quickly is C. C, we have 5 log 3 minus 2 log 9. That's what's in C, 2 log 9. I'll make this a single logarithm. They are all both to base 10. Okay, though the bases are not written. All right, but what I should apply here is the third law, which I will undo this. So I'm going to have log 3 raised to power 5 minus log 9 raised to power 2. See that? And so this becomes 3 raised to power 5. 3 raised to power 5 is 381. 3 raised to power 5. 3 raised to power 5. 3 power 5. 243. 243. Yeah, 243. 243. Sorry, I have to write the logarithm first. Log 243 minus log 9 is log 9 raised to power 2 will be log 81. Okay, and so we can have, of course, by seeing this subtraction here, it implies that I'll have to divide this by this as a single logarithm now. So log 243 divided by 81. See, that is it. So I can simplify my work further. See, 243 divided by this. So I can actually split it up and simplify my work. See, this one came from this. So I have 3 times 3 times 3 times 3 times 3 divided by 9 times 9. See, I can actually simplify it. So this is 9. 3 times 3 is 9. So they can cancel out this. 3 times 3 is 9. They can cancel out this. And so we can have log 3. In other words, 243 divided by 81 is 3. So I have written it as a single logarithm. I have written it as a single logarithm. D. Quickly, D, we have 6 log 2 minus log 8 plus 2 log 3. All right, quickly now, this is going to be equal to log 2 raised to power 6 minus log 8 plus log 3 raised to power 2. You see, I just applied the third law to this, and they gave me this and this. I reversed this. Okay, so 2 raised to power 6 would be 64 now. 64 would be 64. So I'm going to have log 64 minus log 8 plus log 9. And so you see, we have a combination of two things here: subtraction, then addition. Here it means that I'll divide this by this, then the result will be multiplied by this. So that means that as a single logarithm, I can have log 64 divided by 8, everything times 9. That's my result. So it's going to be 8 here 1, 8 in 64 is 8. That's it. Then 8 times 9 is 72. See, this is just very simple, right? Very, very simple. The next question is E. In E, what do we have for E? We have 5 log 4. 5 log 4. I should leave this as a classwork. Okay, let me just do F. I'll leave that as a classwork. Let me do F. In F, we have 2 we have 2 log what? 2 log xy minus log x minus log y. See that? So this would become what? Equal to 2, I'll apply the third law here. This is going to be log xy squared minus log x minus log y. Okay, now if you notice, this is going to be division. Let me take this one first in order not to get confused. Okay, so I can deal with this part first. This would be, because of this subtraction, there is an implication here that we have to divide this by this, so it's going to be log x squared y squared over x, then minus log y. See? All right, so that means that x can go off with x, so we can have log x y squared, okay, minus what? Log y. See that? So this becomes, again, because of this subtraction, again, I can now divide this by this, so log xy squared over y. See, which is the same as, you see, y will go off with one y to give me log xy. Simple. So I have written this one as a single logarithm now. In our next video, we'll solve equations. Thank you.